Welcome back to the Prescott Instruments YouTube channel and to the second part of our linked test on the Rheoline multifunction rheometer. You may also know this instrument by its industry name, the Rubber Process Analyzer, or the RPA. The linked test is a standout feature of this rheometer as it allows you to run multiple test methods continuously in just one test. In our last video, we looked at the first part of the test, the pre-cure strain sweep and frequency sweep. It is recommended that you watch this video first. You can find the link in the description box below. In this video, we begin the curing process, followed by a post-cure strain sweep and frequency sweep, allowing us to measure how the material transitions from a pliable state to a solid state. Firstly, we can see the material curing. We are currently viewing the S' channel on screen, but we have the option to view other channels. You can simply click on the Channels tab and select which ones you want to view. You can also see the channels listed on the right-hand side panel. Viewing S' can be useful because it shows the actual forces generated by the compound during deformation. Now we are running the post-cure frequency sweep, which will show us some key properties of the cured material. This also shows us the long-term structural stability and material degradation of the sample. As mentioned earlier, we can change which channels we are viewing. We are now going to switch from viewing S' to G'. You'll see the graph changes. Now we start our strain sweep. In a post-cure strain sweep, we are measuring how the material's internal structure and elasticity respond to increasing amounts of deformation, identifying its yield point and linear viscoelastic region. This is the zone where the material's elastic structure remains intact and independent of the applied strain. This specific test is highly useful for determining several other characteristics of your cured material, such as the structural strength and the yield point. As strain increases past a critical point, the material structure begins to break down or yield. This test shows us exactly how much deformation or critical strain the cured network can tolerate before it begins to break down. And finally, cross-link density. By evaluating the magnitude of the storage modulus in the linear viscoelastic region, we can gain insight into the strength of the cross-linked network after curing. As we are now viewing the G' channel, we can see that it decreases as the strain increases and the filler network breaks down. Combined with the G', these two channels describe the balance between elasticity and viscosity, providing insight into processability, filler structure, and the expected performance of the finished rubber compound. This is ideal for tyre manufacturers and anyone wishing to establish the properties of rubber compounds. Thank you for joining me for part 2 of our MFR linked tests demonstration. If you have any questions about the MFR or would like more information about our rheometers, please do get in touch at inquiries@prescott-instruments.com. You can also visit our website. Just click the link in the description below. If you enjoyed this video, please give us a like and subscribe to our channel. And let us know, what tests do you run on an RPA? Drop us a comment below. See you in the next video.